Okay, previously we learned that the derivative of e to the u is e to the u times du dx. So it makes sense that the antiderivative of e to the u would also be e to the u plus c. So basically the derivative and the antiderivative of an exponential is also an exponential function. So in the first problem, I'm going to pick my u as 3 over x. So when you see e raised to a power with the variable, try picking that as your u. And this is really 3x to the negative 1. So my du is negative 3x to the negative 2 times dx, which is really negative 3 over x squared dx. So that's why that extra x squared is there on the bottom. So remember, the only thing you can be missing from your du is a number. So let's do the rewrite. So this becomes e to the u. Everything else in the problem is my du. The only thing that's missing is a negative 3. So if I put a negative 3 there, I will have my du. And then since I put a negative 3 there, I need that reciprocal. So now I can go ahead and take this derivative, antiderivative. Antiderivative of e to the u is e to the u plus c. And then just make sure you write your final answer in terms of x. So let's replace that 3 over x. Okay. Number 2, same idea. I'm going to pick 2x as my u. Your du will be 2 dx. The only thing that I'm missing in my du is the 2. So if I put a 2 there, that becomes du. Sorry, I'm going to rewrite everything in terms of u. And then I do need a 1/2. So again, antiderivative of e to the u is just e to the u. And write your final answer in terms of x, though. Okay. Next one, same thing. I'm going to pick negative x squared as my u. My du here will be negative 2x dx. Now, any numbers that are just being multiplied, I'm going to pull that in the front. So I'm going to pull that 5 in the front. And notice that you do have e to the u. And the only thing that you're missing from your du would be the negative 2. So there's my du, and then I need to have that reciprocal. So now the number in the front really becomes a negative 5/2. So this is negative 5/2 e to the u plus c. Go ahead and do your answer in terms of x's. So there's my final answer. Okay, number 4. Your u in this case is negative x. So your du would be negative 1 dx. The only thing that you're missing is a negative 1. The reciprocal of negative 1 is still negative 1. So it just looks like this. So negative e to the u, which is negative e to the negative x plus c. Okay. Now, number 5. So the rule is typically if you see a fraction and everything on the bottom is just raised to the first power, that's a clue that this might fit the 1 over u rule. So usually what I do is I try to pick the entire bottom as my u. And I only do that when the entire bottom is just raised to the first power, not if it's raised to any other power. So your du, notice the derivative of 1 is 0. And then so your du is just e to the x dx. That's why that extra e to the x is on the top. So if you do the rewrite, this becomes u. Notice everything else just becomes du. And the antiderivative 1 over u du is just natural log of u. And then I'm going to plug back in what my u is. So there's my answer. Okay. Number 6. When you have trig functions, look at just the trig portion and think about whether you have an antiderivative for that trig. So there is an antiderivative for cosine. So if that is the case, your u should always be the angle. If that doesn't work, that means your u has to involve one of the trig. In this case, your u is e to the x, your du is e to the x dx. So this is cosine of u. Notice everything else is part of your du. Antiderivative cosine is sine of u. And just go ahead and rewrite the problem in terms of x.